Today we'll be discussing the model we created to most efficiently pick up and charge Lime scooters while maximizing profits within a constrained time frame. Our Lime Juicer optimization project can be considered a Tor network model. The screen you see currently is the scooter's input screen. For our example, we chose Claremont campus as our geographical radius for which we will be picking up scooters from. The user inputs their current location at Claremont from the drop-down menu. So let's say they're at building A. The time available in minutes that they're willing to go out and pick up scooters. So let's say 15 minutes. And then their carrying capacity or charging capacity. This is how many scooters they're willing to carry with them and then be able to charge once they get back to their base. So let's say they want to charge 5 scooters. So then here you input the locations of the scooters you see on the Lime app. So let's input some locations. As well as the bounties associated for picking up each of these scooters. You can input as many scooters as you like, and by simply clicking the Maximize Profit button, our model will find you the optimal path to pick up the selected number of scooters. Our model takes up to a minute to run before it comes back with the optimal path to pick up scooters. When the results are found, the Scooter Results tab will automatically be pulled up. So on this screen, you can see the order the model recommends you pick up the scooters, the travel time between each scooter, the total scooters you pick up at each location, and the total bounty at each location. Then below here, we also have the total number of scooters the user will pick up, the total time it takes to make a complete trip, and the total amount of money that will be made by picking up and charging these scooters. As I mentioned before, for our model, we chose Claremont campus as our base, but these methods can be expanded to any location as long as you know the major buildings or landmarks and the distances between them. With that being said, here's our matrix for the distances between locations at Claremont. Below that is the matrix for the time in minutes it takes to go from one location to the next. Another assumption we are making here is that the user is walking between locations. In calculating, we are assuming an average walking speed for a user as 276 feet per minute, which is the average walking speed for an adult. Our model could also be used for driving distances as long as you know the average time it takes to get from one location to the next. The next tab here is the Optimizer tab, which is a more complete view of the calculations that are going on in the background of our model. Starting here at the bottom left, we have coded in indices for each location at Claremont, which is again shown here in the possible scooter list. The possible scooter list also lists out the scooters that the user has inputted, the count of scooters at the location, and the bounty for the scooters at that location. Moving to the right here, this is the optimal travel route, which is the exact same table that you saw on the Scooter Route tab. And then here is a list of the constraints we have for this model, which include the time constraint the user inputted, as well as the cable or charger constraint the user has depending on the number of scooter chargers they own. Here at the bottom, we are again listing out the final results, the total scooters collected, the total travel time in minutes, and the total bounty. First tab we created is an Instructions tab. Here, we first give instructions on the VBA Excel add-ins that must be loaded into the Excel sheet. In this case, the add-ins are Solver Code and Reset To. We then list our complete instructions for the Scooter Input tab that I have already discussed. And to summarize our whole model again, if a Lime Juicer has a finite amount of time and a finite amount of charging cables, our model allows them to look at an available scooter map and determine which pickup route will maximize their revenues. Thank you for listening, and I hope you enjoyed my discussion of our Lime Juicer efficiency model.